So anytime you're ready, you can start.
Okay. So the first thing that we need to do is turn on the gas cylinder. This is acetylene and this is air. So when you turn it on, it should be above 15 psi for acetylene, and for air, it should be above 50 psi. So the next thing you do is you need to switch this equipment on. So there's this button here which says power, so just switch it on and just wait for like this sound. You'll hear it now. Sometimes it takes a while and sometimes you might not hear it at all. So switch it off and switch it back on. So we'll just wait for a moment and see if we can. Okay, let's try it again. Okay, you heard that? So one more thing, sometimes you don't know if the AAS is on. You just like see, you can see like there's this red light sort of thing at the back. It's just you see a tinge of red. So if that's on, that means your equipment is on. Okay, so now what you need to do is you need to click on shortcut to WinLab 32AA, which is the software that controls this equipment. Okay, you need to wait for a while. This is initializing, like just you saw that it was not connected. So just close it and start it again. And if that thing is being repeated again and again, just restart the system. Like switch it off, then switch this equipment off and then restart the computer. Okay, so now this is ready. The first thing that you need to do is select the lamp. Now I am going to demonstrate this this experiment with copper. So just click on lamp and you'll see lamp 1, lamp 2, lamp. You don't need to know what's inside because even if you change the lamp, it'll like show up on this screen directly. So don't worry about it. Now I'm working on copper. So what I do is I select lamp 2. Okay, so it'll adjust everything on its own. The settings required for copper, it will do it on its own. And one thing that I did show is now this lamp is a multiple element lamp. So do you see CU over here? So when you click on it, you saw that small triangle over there, right? So when you click on it, you'll see Cu, nickel, chromium and silver. So you can just select whatever you want and it'll change it accordingly. So, but you need to click on lamp 2. Sometimes if you click on and off, it'll just turn on the lamp. it won't like apply the settings. This is what I think happens. So you need to click on lamp 2 and then just wait until there's a change in the energy. Also have some Kim wipes or tissue ready, because every time you put it into the standard or your sample, you need to clean it. If you hear that sound, it's good. Sometimes you don't hear it at all, so you need to restart it. And we are lucky that this is working right now. Sometimes it won't work, you'll have to restart it, but it will work. So this means that it's ready for analysis. So you close the window, and then it's very easy. Then what you need to do is you need to select the method. Now I prepared my own method. So you can either prepare your own method, or you could like have one already prepared for your lab. Either way, it does not take a very long time. So, or you could change an existing method. It doesn't take long at all. So I'm going to use my method. This says CU determination. Just click on it. Okay. So it shows you the method editor. Like I said, if you want to change something, for example, let's talk about calibration. I want to work on 5, 10, 15, 20. You want to work on 1, 2, 5, 10. So you just change it over here and what it represents. So like if it's 5, I know it's 5 ppm. So it's basically I'm just telling the equipment that level 1 is 5. And you could have like one more blank, you could have a standard in between, anything, you could keep adding. Then you could, like, I use linear equation through 0. It will give you y is equal to mx form, okay, but I use y equal to mx plus c form. And I have noticed that I don't get good results with linear calculated intercept, so I always set it on linear through 0, and then I replot my calibration plot and get my equation in the form of y equal to mx plus c. You can adjust your decimal places, significant figures, your units, everything you want. And then say you want to like test the same sample 4 times, 10 times. I set it to 3. You could have like 5, 10, whatever. It doesn't matter. And so that's about it. Close it. Then what you need to do is you need to turn the flame on. So you click on flame, and you don't need to change anything. It changes everything on its own depending upon what element you are analyzing. So I just switch it on. Sometimes the flame won't go on. That could be because of the pressure. The cylinder, there might be no gas, or it could be below 50 psi or 15 psi for acetylene. You need to just be careful. So close it. Then you click on manual. Okay. Now it's very easy. This is my blank, which is DI water. What I do is, see, if you just like come closer and see, you can like, when you just if you feel this thing, you can feel the you can feel the pull. So if you feel it, then it's working fine. So I clean it and then I put it in my blank and I click on analyze blank. So it'll do everything on its own. put it back. And then this is my 5 ppm solution. You can test it again if you want, like click on it again, analyze blank, you'll get it. So clean it and put it in your standard, and I wait for like 2 seconds. Even though it initializes the sample, I wait for 2 seconds and then I click on analyze standard. So 5 ppm is recorded also. And like say you want to see your results side by side, you can always just click on results and like put it on the side and just wait, like if you want that.
How will you know whether it's okay now to like move to the other?
It says idle.
Oh, okay.
So you'll know when to like. It says even over here or over here. Just see. Like I'll show you this run. Analyze standard. See, it's initializing. It'll check AGC and yeah. See, it's reading. And it gives you the correlation coefficient, R square value, intercept, depending upon what sort of equation you want to use.
So when it's idle, it's ready to.
Yeah. And make sure you don't pull this tube too much. It's sensitive and it might not give you like good results. So sometimes when you're in a hurry, you tend to pull it. So just be careful with that. Okay, so now we're done with your standards and this software is pretty neat. So once you're done with your standards, like I have 5, I have 4 standards. So once I'm done with all 4, it will give me like a calibration table. So you just need to, you can just input this in Excel and get your plot. And if you see your correlation coefficient is like R squared value is 0.993, which is pretty good. So it's a pretty good calibration plot. Well, this is my sample. So what I do is I clean the tube and then click on analyze sample. Very easy. So I get 4.9. It calculates this based on your correlation coefficient and the slope. Not the correlation coefficient, sorry, the slope. Yeah. But I would not use their value of slope because, as I said, I prefer y equal to mx plus c. And it's better if they get their own plot and then calculate it from their plot. My second sample is animal. I wouldn't even use the concentration given by them. As I said, it, I calculated again. It's pretty close, but as I said, it works for me. Yeah, better. So yeah, that's it, done. now I'll show you how to like generate a report. So now when you're done, you just need to close this, click on save, and switch it off. And then click on bleed gases. So whatever is left, it just goes down there. So it's a good idea to always bleed gases after you're done with the experiment. And don't close this window because now you're like done with the experiment and I still have to figure out how to like reopen the closed results. So try not closing it. So these are my results. Click on File, Print, Active window, since this is your active window, and just okay, and I can save it as like save it however you guys prefer. Yeah. Okay, this happens a lot. This first page is blank. Like if you're lucky, you might just get a very good result. So what you do is you just print it again. Print active window, okay. Replace it, yes. There you have it. Yeah. So it's saved wherever you saved it. In this case, the desktop. And then just put it in your flash drive. And if you see, it gives you the calibration data for CU 322.75, which is the wavelength at which the copper atoms absorb. So this is your data, and this is like your sample ID, sample 1, sample 2. So you don't, it's all there. So you close it, and then close this, file, exit. Do you want to quit using WinLab 32? Okay. Sample information has changed. Do you want to save it? So you select yes and just like save it however you want. Save, and it will ask you, would you like to turn off all lamps? Make sure that you click yes and just don't switch it off directly. It's not good for the lamps and they're pretty expensive. So make sure the lamps are turned off before you close this software and your equipment. So it's shutting down, and once that is done, just switch it off and turn off the cylinder. Yeah, it's done.